Okay, so I just downloaded and made a copy of the example lab that I had posted about Boyle's Law. And I changed it to my last name, lab report, and now it's about Amonton's Law. So this was the relationship between what we actually measured, which was temperature. So we controlled the temperature and measured the pressure. I don't know what day you submitted it. Maybe you submitted it yesterday. And this is 22. I think we did the lab on the 10th, etc. Okay, so we're just changing all this stuff to match. Okay, so now we can hear you don't have to change what's going on. The purpose of this lab was to determine the mathematical and graphical relationship between pressure and temperature. So we're going to change this to temperature when the volume and the number of molecules is held constant. The independent variable in the experiment was the thing you controlled, which was temperature, and the dependent variable was the thing you measured, which was pressure. So that's still the same. The volume was controlled by not this, right? So this was changed. The volume was controlled by having a solid glass Erlenmeyer flask. And then measuring the pressure using a pressure sensor attached to the syringe as the temperature was changed using a water bath. Okay, so you could have said something different, but as long as you're explaining the how the experiment worked. So we controlled volume of the Erlenmeyer flask and measured the pressure using pressure sensor as the temperature was changed using a water bath. I don't know, you could even say like around the Erlenmeyer flask. Okay, what did we think would happen? It was hypothesized that as the volume, well, we didn't do that. So it was hypothesis as maybe as the temperature increased, right? Because we were like heating it up from cold. As it was hypothesized that as the temperature increased, that the pressure would increase, and vice versa, because as the temperature increases, the molecules would speed up and collide with the container more frequently and therefore increase pressure. So notice I didn't change many of the words. I actually kept a lot of the structure the same. Okay? So it is okay for you to go through and just use the template and change what's actually happening. That's why I provided this with you. This is the first lab reports you've written in your entire life probably. So I'm utilizing this structure to help you phrase your words because it's different than fiction writing, right? Where you get to like make things up. This is nonfiction. I'm not going to do this part for you. You can change your materials, you can change your procedure, make sure that it's in past tense. And so now you have data and observations. So you should have a data table here that instead of volume and pressure, you should have temperature and pressure. And then you should download the data that you got from your group member, or maybe you didn't save it, maybe you only wrote it down in your lab book. And so you can insert that data here. I'm going to pause real quick. Okay, so I'm going to change my data table to be the data that was collected in the lab. So, oops. Here it is. So I'm going to insert my data table that I collected instead. Oh, that didn't work. Let's just delete this one. No? Okay, so the formatting on this is kind of crappy. Hold on. There we go. Okay, so I have these temperature and pressure data points, which as you can see, like, kind of went in here weird, so I could move them and just fix the formatting so that it doesn't look like this. But these are my data points. So I've got temperature from 5 to 85 Celsius, and then pressure from 88 to 107. So once you have your data table like looking better, maybe you made some observations, like some brief observations that maybe yours ended up did the top pop off when you reached a certain temperature, or did it not? Many of you also discovered that the temperature could not go over 100, right? So no matter how much you kept heating it, the temperature and pressure became stagnant once you hit boiling, because then the water evaporates and you can't get any hotter than that. So that could be one of the observations that you made during the lab, is that you couldn't get any hotter. Okay, so now in your results section, you're going to have a couple things that aren't in this one. First of all, many of you have told me you don't know how to make a graph like this on Google Sheets. So I'm going to show you how to do that. And then you can insert the graph here. And the other thing is that you're actually also going to have a calculations section in here. Because unlike in Boyle's Law, in the lab report write-up, I ask you to figure out basically absolute zero using your data. So how do we turn our data over here into a graph? So let's go to, I'm going to zoom out here. You're basically going to open up your, so if you haven't done this, do it right now as you're following along. I'm going to open up my drive. I'm going to get a new Google Sheets. Okay, so we're going to use Sheets. In the past versions, this was Word, which was called Excel. So there are very similar things between Excel and this Google Sheets, but they're not exactly the same. So I'm going to copy my data again and paste it into here. Okay, so I'm going to make two columns, the first one being temperature and the second one being pressure. Notice that I don't have any letters in my data here. Okay, if you put letters, it doesn't know how to graph a letter. It can only be numbers. So that's why at the top I put what the unit is. So this is temperature parentheses degrees Celsius and pressure in kPa. But do not put it in here, otherwise it won't graph correctly. Okay, so I'm going to highlight my data like that. Okay, so now my data is highlighted. I'm going to go to Insert Chart. Okay. And it knows that I like scatter plots. It might, instead for you, have made something different, but I want a scatter chart. So you can change what type of chart it is over here, and I put it on a scatter chart. So pressure versus temperature. Notice that it did already put pressure and kPa on my y-axis because I set this up as x and y. And so temperature is down here. It picked a scale for me, and then you can find all of the information that I asked you to calculate using this program. So if I click on my dot and I go to, let's see, I want to insert a line. Let's see. Okay, so over here on Chart Editor on the side, if I scroll down, you're going to get these options that say error bars, data labels, and trend line. So let's add a trend line. And I don't know about you, but this looks like pretty flat. So that's called a linear regression. You could have exponential, like Boyle's Law. You can have other types you've learned about in math. But this is linear. I mean, I could change my line color, all these things about it. I'm going to give it the equation. Look at that. It just did the y equals mx plus b for me. Okay? So using these exact data points, it made a best fit line, and it calculated the slope of the line for you, instead of having to do it on paper. And then I also want to show, no, I don't want that, sorry. If you know what r squared is because you've learned about it in Algebra 2 or Pre-Calc, it'll also give you that. So r squared is basically how well do your data fit. So this is almost 100%, 0.995 is pretty good. So it means the data that I collected in the lab was almost perfect. Okay, so that's what the r square is. Okay, so now I can basically click on this. It looks pretty good to me. I'm going to hit Control Copy. I'm going to go back over to my lab report, delete this one that I had made in the Boyle's Law one, and insert unlinked. There we go. Okay, so now your chart is in there. It has this fun stuff about your y equals mx plus b, and then you can start writing your conclusion. Your calculations, one student reported to me that they couldn't figure out how to do like easily make the equations in here, which I agree is kind of clumsy. So they did their stuff on paper and took a picture and then just inserted the picture here into the calculation section, which I think is totally fine. As we do more complicated lab reports, I'll show you how to do calculation sections a little differently. Okay, so now in your conclusion, what should be here? Well, again, it's pretty much almost the same exact wording that you're going to have. So the purpose of this lab was to, you literally just copy paste from your first sentence in the introduction. It was found that. What did we find? Well, using this graph, it looks to me like these are directly proportional. So as one goes up, the other goes up as well. So it was found that as temperature increased, pressure also increased, which is a direct relationship, okay? I mean, you can use your own words. Those are my words. And then I guess we could leave this when the number of molecules and volume are held constant. As shown in data table 1, which is now temperature versus pressure, this happened and this happened. So you're going to use 2 data points. So you would say like at 10 it was at 90, but then at 60 it was at 102. So you're using a data point to prove your statement. So your thesis statement is here. It was found that. So now you're going to use some supporting detail here to prove that. So use your data. You could also then say, as shown in the graph of pressure versus temperature, this also supports the conclusion. For example, at this happens. And when the pressure is, or when the temperature is half, this happens, okay? I also want you to answer the discussion questions that were in the book. So that is one thing that's not in your example conclusion. So in your book it says, under Amonton's law, that I wanted you to calculate the slope, which we now had our graph do that for us. And it says, write the y-intercept form. Using your equation, predict the pressure at 273, oh, that should be Celsius, actually, for number 6. So predict at 273, and then explain what you just determined in the discussion section of your lab report. Okay, so that was in the book on page 11. Okay, so what does that do? So notice that this has a y-intercept right here of 87.3. Okay, so you're basically extrapolating where does this line finally cross the y-axis, and that has a meaning, which you did learn during gas laws as a freshman, and might have something to do with Kelvin. So I'm not going to tell you on this video. You could ask each other or ask me later. And then after you have that discussion question there, then, that's not how you spell discussion, you can talk about your errors. So, was your valve leaky? Did the top pop off? Did you get it too hot? Maybe even the temperature probe itself, when it was sticking in the water bath, I think the end of it was touching the hot plate. So was the temperature that was recording actually the temperature of gas inside the Erlenmeyer flask? Probably not. So that could be another thing that you could talk about. To make this like even better, like if you go on to write these in the future, you could also say, how could the lab be improved? Okay, so think of one thing that you could change to have made it better. Okay, thanks for watching this video. Now that you've watched it, you should be able to create a pretty amazing lab report. Don't forget to also look at the rubric that I posted to make sure that you have each of the check boxes on the rubric that I'll use to grade your lab report. Okay, happy Valentine's Day.